Okay, so here's the last part of section 3.5. How do you graph these things? How do you graph these rational functions? And that's what today's talk is going to be about. This page is from the textbook, and it's also on that section 3.5 cheat sheet that you all got yesterday. We're going to go through these steps. I'm going to give you a few examples. We're going to go through each step on each example to show you how to do these. So let's take a look at the first one. Here's the function I want to graph. Notice it's a rational function, rational polynomial function. We got a polynomial on top and one on the bottom. So the first step is going to be finding our vertical asymptotes, if we have any. So I take my denominator, I set it to 0. Then I have to factor it so that I can figure out where the x's are. It factors like this. So I set each one of those to 0. So I'm getting x equals 3. I set x plus 2 to 0, and I get x equals 2. From what we talked about yesterday, you know that you've got vertical asymptotes at x equals minus 2 and x equals 3. That's step 1. Now the degree of the numerator is less than the degree of the denominator. So what does that tell me? It tells me that for horizontal asymptotes, I've got one at the x-axis. In other words, y equals 0. And again, it's because the numerator's degree was smaller than the denominator's degree. Next thing I want to do, I want to find the y-intercept. So I take my complete function and I plug in 0 for my x's. Here's what I'm getting. It comes out to be positive 1/3. So I know that my y-intercept is at the point 0 and 1/3. This is all important information for the graphing that we're fixing to do. Step 4 is get the x-intercepts. Well, how do I do that? I take the numerator of my fraction and I set it to 0. Then I just solve for x. X equals 2. That tells me that's where my x-intercept is. I've only got one. So it's at the point 2, 0. Let's go to step 5. Now I know my horizontal asymptote is y equals 0. So I use that fact, and I'm going to set my whole function to 0. Then I'm going to try and solve it. So first thing I do, I multiply both sides by x squared minus x minus 6. So now I've got x minus 2 equals 0, which means x equals 2. Now realize what this is telling you. This is saying the graph will intersect that horizontal asymptote at the point x equals 2. And we would use the same sort of thing to find where it intersects the oblique asymptote, but in this case we had a horizontal one. So now I'm going to start putting the information that we got from those first 5 steps onto a graph. First thing I'm going to do is put my vertical asymptotes. Those are the green lines at x equals negative 2 and x equals 3. Next thing I'm going to do is plot my y-intercept. It's at the point 0, 1/3. Next, I'm going to put my x-intercept It's located where x is 2 and y is 0. So those are my two little red points right there. I also know that that last point, the 2, 0 point, is where the graph will intersect my horizontal axis, my horizontal asymptote, which is the x-axis. So it's going to intersect the x-axis right there at the point 2, 0. So far, that's all I know. So I'm going to get some extra points and plot them. So I'm going to start on the left-hand side, and I want to point to the left of that vertical asymptote at x equals -2. So what I do is I just say, what's f of -3? So everywhere there's an x, I put a -3. I figured it out, and I'm getting -5/6. So I plot that point in black. I'm using colors just so you can see what I'm doing a little bit easier. Well, okay, there's one point out there to the left of that asymptote. Let's get another one. This time I'll say, let's go all the way out to x equals -5. I plug the values into our function, and I'm getting -7/24. I plot that point. Notice it's closer to the x-axis than my first black dot. So what's that tell me? I know that the graph cannot touch that green line. I know that the x-axis is a horizontal asymptote, so I can sketch the very first part of my graph. Rough sketch, I know, but that's probably what it's going to look like. And notice it's getting closer to the vertical asymptote and closer to the horizontal asymptote. Now I want to find out what's going on in between my two vertical asymptotes. So I picked -1. I put the black dot there. Here's how I figured that out. F of -1, I substitute -1 for every x, and I'm getting 3/4. So my point there, the black dot, is at -1 and 3/4. Well, that's enough information to sketch the middle part of my graph. Remember, it's got to be in between those two vertical asymptotes. And based on where my dots are, this is the only way it could go. So this looks like a three-part graph here. I need a point to the right of my vertical asymptote at x equals 3. So for mine, I just picked 4. I plug 4 in, do the math, and I'm getting 1/3. So at the point 4, 1/3, I'll put a dot. There it is. Let's get one more out there to the right of that horizontal asymptote. Now I picked 7. You don't want to pick points that are too close together because there won't be much difference in the y values sometimes, and it really won't help you very much. So I picked 7 to get away from that 4. I'm getting 5/36. Let's plot that one. So you can see it's even closer to that horizontal asymptote, the x-axis. Well, just based on those 2 points and the vertical asymptote, I can sketch the rest of my graph. It's going to look something like that. Now, y'all remember, we're doing sketches. We're not plotting a bunch of points. We're just using the techniques of using asymptotes, y-intercepts, x-intercepts, and any other information we need just to see what the curve is doing. So there's example 1. Example 2, let's graph this thing. Looks a bit more complex than that first one. Let's see what it looks like. So step 1 is to find vertical asymptotes. So I'm going to take my denominator, set it to 0. I'm going to factor it. so I can find out where my x's are. It's a perfect square trinomial, so I'm getting x plus 3 times x plus 3. I set x plus 3 to 0, and so I get x equals negative 3. Well, that's where a vertical asymptote is. I'm just following the list of steps on our cheat sheet. Okay, how about horizontal asymptotes? Now, in our first example, the degree of the numerator was smaller than that of the denominator. Here, the degree is 2 in both of them. So what do? We just make a fraction. Now remember, there's a 1 sitting here in front of that x squared. So I just make a fraction 2 over 1. Because the numerator's degree is the same as the denominator's degree. What does that tell me? It tells me that the horizontal line y equals 2 is our horizontal asymptote. Next step, I want to find my y-intercept. So I take my function. I'm wanting to say, well, where does it cross the y-axis when x is 0? So I plug 0 in to my function. Any place there's an x. Here's what I'm getting. When I figure it out, I get negative 4/9. So at the point 0, negative 4/9, I know that's where my y-intercept is. Now to find the x-intercepts, I take just the numerator and set it to 0. Then I start trying to find out solving for x. Well, I tried factoring this one. It didn't factor very well using the AC method. So I'm using the quadratic formula. I just plug my values in. And here's what I'm getting. Now then, since we're plotting this on a graph, I can't just leave my numbers exact like that. So I had to round them off, and here's what I got. I got an x-intercept at about negative 2.4 and about 0.9. Now those are rounded off. If you graph this in Desmos, you could get a lot more exact answers. But remember, we're making a sketch. The next thing I want to do is to see if my graph intersects the non-vertical asymptote. Well, that means that horizontal one. The horizontal asymptote was at y equals 2. We just figured that out. So what I do is I take my function, I set the whole function equal to 2, which was the horizontal asymptote. So I multiply both sides by the denominator. Distribute that 2 across everything. And then the next thing I do is see if anything will cancel out. Well, those 2x squares will, which leaves me with 3x minus 4 equals 12x plus 18. I do a little algebra 1 on it here, and I get 9x equals negative 22, or said another way, x equals negative 22 over 9. So when you divide negative 22 by 9, you get about 2.4. So that's where our graph is going to intersect that horizontal asymptote. So let's try graphing this thing. The first thing I want to do is put my vertical asymptote at x equals negative 3. Then I'm going to put my horizontal asymptote at y equals 2. That's in purple. Then comes my y-intercept at 0 and negative 4/9. Next, I'll put one of my x-intercepts at negative 2.4, and the other one is about 0.9. This is based on the information we just calculated. So I want to figure out what's going on to the left of my vertical asymptote. So I'm going to pick a value like -5, plug it into the function, and see what the y value is there. When I do that, I'm getting a y value of about 7.8 when x is -5. So let's plot that point. And now I want to go even further left and maybe pick -10, just to make sure I'm seeing what's going on out there to the left of that vertical asymptote. So at x equals -10, the y value is 3.4. Let's plot that one. Okay, now then I've got a good picture of what's going on out there to the left of the vertical asymptote. So I'll go ahead and sketch that in. Next thing I want to do, I want to find out what's going on between the vertical asymptote and the y-axis. So I'm going to choose the point x equals -1, and let's see what y value we get. All right, when x is -1, y turns out to be -1.25. I'll plot that one, a black dot. And now I want one to the right of the y-axis. So I want to go out a few steps, like maybe x equals 6. When I plug that value in, I find out that at x equals 6, y rounds off to 1. So let's plot that one. And now I can tell pretty much what's going on from the vertical asymptote all the way out. So let's go ahead and sketch that. Make sure you see that the graph never does touch the vertical asymptote or the horizontal one. Now it crosses it. It does cross the horizontal asymptote, but we knew it was going to do that from figuring out step 5. Okay, last example. I want to find my vertical asymptote. So I set the denominator to 0, I solve it, and I realize I've got a vertical asymptote at x equals 4. I'm looking at the function, and I'm realizing that the degree of the numerator is exactly one bigger than that of the denominator. So I know I don't have a horizontal asymptote at all. But what I do have is an oblique one. And so what I have to do is divide the top using synthetic division. Notice I needed a placeholder for my x value. And I'm going to divide by 4 synthetically. I'm getting this. I cross out the remainder, and so what I'll have left there is 2x plus 8. So I know I've got an oblique asymptote at y equals 2x plus 8. It's going to be a slanted line. Now I want to find my y-intercept, so I take the function, plug in 0 for all my x's, and it comes out to -3/4. So I know that my y-intercept is at the point 0, -3/4. To find the x-intercepts, I take the numerator, set it to 0, then solve for x. Now I'm getting x squared equals -3/2. That's red flags are going off. So x equals plus or minus the square root of -3/2. Well, that's an imaginary number. So what do you get from that? There are no x-intercepts. This graph doesn't cross the x-axis anywhere. Now to see where the graph may or may not cross the oblique asymptote, this is a reminder that the oblique asymptote, the equation is y equals 2x plus 8. So I take my original equation and set it equal to 2x plus 8. I want to see if they intersect. multiply both sides by x minus 4. Four on the right-hand side over there. And I'm seeing that those 2x squares will cancel out. Over on the right-hand side, I've got plus 8x and negative 8x. They'll cancel out. Well, what does that leave me? 3 equals negative 32. Well, that's false. So that tells me the graph does not intersect that oblique asymptote. So that's good to know. So let's graph what we know so far. I've got a vertical asymptote at x equals 4. I've got this oblique asymptote in purple. I've got my y-intercept at the point 0, negative 3/4, the red dot. What else did we get from what we figured? Well, one thing, we know that the graph never crosses the x-axis. That's going to come in handy. So let's see what's going on out to the left of the y-axis. I'm just going to pick a point, negative 5. I plug that into my equation, and when x is negative 5, my y value is about negative 5.2. I plot that. Now I realize that this graph is never going to cross the x-axis. So from that black dot to my y-intercept red dot, I know there's going to be a curve going on there. Let's see what happens between the y-axis and our vertical asymptote. So I'll pick a number in between there. I chose 2. I plug that in and rounded off. The y value when x equals 2 is negative 5.5. When I plot it, I see that my curve is going to come starting over there at the left on that negative 5 point and make a curve and then head down, never touching that vertical asymptote. So it's going to look like this. But notice it does not cross the x-axis. And it doesn't touch either one of the asymptotes, the oblique or the vertical. So let's see what's going on to the right of our vertical asymptote. Pick a number out there. I chose 6. So when x is 6, y is 37.5. I went ahead and picked another one at 10. When I figured that one out, when x equals 10, y equals 33.8. So let's plot those. And I know my curve is going to be between the vertical asymptote and the oblique one. So with those 2 points, I can sketch my curve. Like that. Nowhere does the curve cross the x-axis, nor does it touch either one of the asymptotes. So there are 3 examples to help you figure out how to graph these. Each one's a little bit different, but by following those steps on the cheat sheet, it's going to make it easier. The more of these you do, the better you'll get. If something doesn't make sense in this video, just email me. Ask questions. I enjoy questions, believe it or not. So otherwise, see you next week.